Native DSD is basically the implementation of a dream that I had some 60 plus years ago. What could it sound like if I could actually hear what was heard out of the microphones in the studio? That's what Native DSD does.
The Fidelity Exchange, pulling back the curtain on brands shaping high-end audio and more.
Hey everyone, and welcome to the Fidelity Exchange. I'm Drew Baird from Moon Audio, and today we're diving deep into something that affects every audiophile's listening experience, high-resolution audio, and why it actually matters. I'm joined by Jonas Sacks, co-founder of Native DSD Music, and Tom Caulfield, the Grammy Award-winning mastering engineer. Jonas, Tom, welcome to the Fidelity Exchange, and thanks for joining us.
Thank you
for having us.
So Jonas, what was sort of the aha moment about high-resolution audio needing its own platform?
Well, I grew up with a lot of musicians around the house. I have two parents that were trained as classical players back in Amsterdam, where we've lived throughout this time. So my dad combined his love for music with the excitement of recording at some point, and then he thought, well, actually, I like the recording part even better. So he kind of dropped playing and started recording, and did over 650 mostly classical recordings, and produced them as well, and aside from engineering them. And I was around the house playing, and I would be around all these musicians, so that was really cool. So that's how I also started playing the trumpet, and later also developed this love for film and photography. And that's how I kind of got onto his recording sessions, or let's say locations, really, and started doing the videos and photography needed to promote these projects that he recorded. And then at some point, he was doing DSD and DSD recording already since the early 2000s. And then at some point was like, well, we have this SACD that we're selling, but it's not doing quite well. Why can't we also sell these, original files that we use to create SACDs? And that's how the idea was born to start a platform really to sell these files, not just for his label, but also for, other labels that we knew. And so we started with just about 4 labels, and back in 2014, and then quickly other labels caught on, and we expanded from there, and now we have close to 4,000 albums available. So that's kind of in a nutshell how we got here.
And so Tom, you've got a mastering engineer background. How did you come to jump on board with Native DSD?
Well, I was working with Jared when he had a site which was Channel Classics exclusive. And from that, in conversations with him, as Jonas pointed out, it was how could we broaden this? The site was successful, but it wasn't reaching as many people as could be met with the highest resolution recorded music.
Very interesting. There's a lot of different digital formats out here, and you said something interesting at the beginning, Jonas. You're selling basically the virgin files, right? The original DSD recordings that you guys are doing in the studios. And, there's a lot of other formats going on out there, and there's obviously a whole bunch of different conversions that go on. Maybe I realize you guys are just touching on the virgin aspect of just pulling the DSD straight through to the consumer, which is fantastic. Maybe touch on some of that information of, why are all these different formats there, and why aren't we using the original, if you will, virgin files and so forth? Why are a lot of companies, changing, from if the original was DSD, why are they changing it to PCM and all these other things? You know what I mean?
I think for a long time, delivering the original wasn't even possible, right?
Yeah.
It would be these huge reel-to-reels, and, we would have cassettes because that was easy. It was portable. The same thing for CDs and SACDs. And then now streaming is also, everything is funneled into a tiny little hole to deliver it really quickly all around the globe. It's
Right.
all a matter of, what's practical. How do we get it to a consumer? And I think now that's changing, at least from our perspective, because of the internet speeds quickly developing. We're able to deliver a really big, DSD original recorded file straight to the consumer.
Mm-hmm.
And of course, you have to want to get into a big, sometimes 50 gig file for one album.
Yeah.
It's a bit cumbersome. You have to move it around and, probably have a server or a DAP with a lot of space to store these files. Yeah, that's definitely changing quickly now. We see a lot of people downloading huge amounts every month,
Yeah.
from
Yeah.
our service.
To best understand how this came about, uh, perhaps a little delve into the recording industry would be useful. Through most of the 20th century, analog was the media that was used to transcode what was available from microphones to some storageable and not so much processable but deliverable formats. That was, of course, a combination of mechanical, which vinyl is an example,
Mm-hmm.
optical, which is on film, and um, later and towards the late 40s through the 50s, tape, which used magnetic transcoding onto a ferrous material. The thing that was common in all three of those was they were a continuous stream of information. In the late 50s, early 60s, there was work developed on a digital format, and that became usable in the very early 80s with the CD, and that was PCM. PCM is a form of recording that's analogous to film. That is, in film, there are discrete images or discrete standalone pictures that are
Mm-hmm.
chained together that, when run in a sequence, gives the iBrain information to imply motion. PCM is exactly the same. That is, there are samples or measurements, measured values of the amplitude coming from a microphone that are strung together, and the ear brain perceives this as a continuum, but it's not. They're discrete samples. DSD, or its actual technical name, pulse density modulation, as opposed to pulse coded modulation, is a form that is completely different than PCM in that uh, in PCM, you wind up with a bunch of, or a sequence of, digital value samples. And these values can be computed directly because they're basically binary digital words of some depth at some rate. PDM, or the 1-bit variant of that, which is DSD, is a modulation of a carrier, exactly like radio. In radio, uh, you're modulating a very high frequency carrier used for transmission
Mm-hmm.
with an audio spectrum, which, when decoded at the end, takes the carrier away and leaves the original modulated audio. PDM, or DSD, which is the 1-bit variant of PDM, is the same in that you have a carrier. In this case, it's a square wave, uh, also known as a bit clock, and you modulate that bit clock or square wave with the audio, and on playback, you strip out the bit clock and you're left with the audio. The important consideration of that is that, unlike PCM, PDM is continuous because the bit clock is continuous. The bit clock is so much higher a frequency in PCM, for instance. The average recording today is done at 96 kilohertz.
Mm-hmm.
96 kilohertz is about twice the frequency of the highest frequency that you'd like in the audio band. In PDM, it's almost 3 orders of magnitude greater than the audio bandwidth. So you have so much continuous information being encoded that when the carrier is taken back out, which is what the DAC does, you have now audio that has, as close as is technically possible today, the original audio.
You know, you brought up an interesting thing about clocking that you said, and a lot of our customers are very confused about word clocks and why they make a difference in audio. And it sounded like you said that word clocking with DSD is a lot more critical than with PCM. Is that correct?
There's no such thing as a word clock in PDM or DSD because there are no samples. That's the disadvantage of PDM or DSD, in that there are no values associated with it. It's simply a modulated carrier. So a word clock is associated with PCM because the original rate of commercial recording, which was 44.1 kilohertz, is considered the fundamental basis frequency that things are recorded at. So word clock is a clocked frequency associated with 41 kilohertz, 41.1 kilohertz. So therefore, if you are trying to synchronize something, you'd like to give it you have to have some form of timing signal, better known as word clock, to clock these frames together such that they live in the time segment that they were originally recorded in. PDM, DSD, has first of all, no samples, no values, so therefore has no clock associated with it. It's just a continuous stream of bits that are, in fact, reflecting the level over time of the density of ones versus zeros or zeros versus ones of the original modulating audio.
There was an interesting analogy earlier that you're saying that PCM is like a movie film and
Right.
DSD is like radio.
Sure.
So why do you think radio is better than film in terms of the way it's broadcasted or converted and so forth? Does that make sense? It sounded like you said that, it almost sounded like you said that in that analogy that the way radio signals operate was a better format and how that translates to DSD and PCM? Or maybe I missed something
No,
there.
I'm sorry if I implied that.
I'm just talking about from an analogy standpoint. Obviously not really looking at those two things, movies and radio, but you use that analogy and I'm trying to correlate how that sort of pertains to what we're talking about.
The difficulty with PDM or PCM is the available hardware today to operate at frequencies that remove the audio from the whatever either frame rates or sample rates in PCM or clock rate in PDM. So remove it that it doesn't have any effect when you take it back out. In all cases, to reconstruct the audio, you need to filter it. And the filtering process is such that any filtering process steeper than 6 dB per octave, which is basically a Gaussian filter, any filtering activity has phase effects, whereas a pure Gaussian filter has no phase effect. It's completely neutral. When you talk about PDM, for instance, if the basic clock rate is 11.6 megahertz, which is what DSD 256 is, to get the components that make up that carrier out, and out means down about 100 plus dB, requires a filter that is not Gaussian shaped. It is shaped appropriately such that the base frequency, the 11.6 megahertz, is down at least 120 dB at 20 kilohertz. That's a pretty mild filter compared to what it takes to get the same amount of attenuation from, let's say, 96 kilohertz, or worse yet, 44 kilohertz, down such that it doesn't exist anymore at 20 kilohertz. I'm not sure if that answered your question.
Maybe I didn't. My question might have been a little confusing because I sort of got a little bit lost in the correlation. But in our intro call, you stated DSD is analog, not digital, and I think for people that may not be aware of this analogy. Can you dive into that a little more?
Sure. When I say it's analog to the degree that the encoding carrier is such a high frequency compared to the audio spectrum that the spacing, the intervals between captures. It's not. I don't want to use the word sampled or anything derived by sample, because it's a modulation. The analogy to a radio transmission is simply to conjure up the concept of a audio spectrum modulating a carrier for a purpose. In radio, the purpose is transmission. In audio recording, the purpose is to get the continuous audio onto some media that then can be retrieved without losses.
Yeah, next to a radio wave, you could maybe think of a needle going through the vinyl. The landscape of the vinyl. That needle either kind of goes up or down, and it's not fixed into a certain value.
Hey everyone, Future Drew here. Just wanted to clarify a few things about DSD for both our viewers and listeners. DSD is actually simple in concept. It's a way of representing audio using a very fast on-off signal, somewhat like how radio carries audio using a high-frequency wave. What makes DSD confusing is that people try to understand it the same way they understand normal digital audio, which stores sound as a series of numerical samples. DSD doesn't work that way, and trying to fit it into that framework only makes things more complicated. With DSD, the audio is carried by a rapid stream of pulses, quick jumps between a high level and a low level. You can think of the high level as a 1 and the low level as a 0, but those 1s and 0s don't represent numbers. They're simply markers that let a computer store and retrieve the pulse pattern. The pattern itself behaves more like an analog signal, just packed into a form that looks digital. This is very different from PCM, which is made of actual numerical snapshots of the audio that a computer can read, process, and manipulate directly. Because DSD doesn't contain these numerical values, it can't be edited or processed inside a computer without first being converted to PCM. DSD was originally created by Sony as a high-quality archival format for preserving recordings, and only later was it adapted as a consumer delivery format to support and differentiate SACD. Anyway, back to the interview.
But the point I'm trying to make when I talk about PCM versus DSD or PDM is that they are different technologies that are trying to do the same thing, which is to capture a continuous stream of level changes coming out of a microphone into a format that can be managed or delivered or processed back to a consumer who then does take that deliverable product and makes it back into analog, which it was derived.
Right.
The reality is that all initial conversion available today is done in PDM. All 880 converters are sigma delta modulator front-ended. So anything that then changes it from that original PDM modulation to what is delivered to the customer is a conversion, and those conversions are done for a reason. But all conversions are lossy. So each time you convert from one form to another, you lose something. And you do that in order to gain something, obviously, but you do lose something. What Native DSD specializes in is acoustic music. And in acoustic music, the primary objective is to encode or record the timbre of the instruments, the space that the instruments are located in or playing in, and basically bring the user into that environment. DSD does that much better than PCM does that because it is what encoded it in the first place. And if you could retain that and stay in that mode or in that media, you would have fewer losses. Unfortunately, that's not the way the recording industry works, because, again, the fundamental encoding of the analog mic channels need to be processed in one form or another. So, by and large, 99% plus, 99.9% of recordings made today, while they're recorded in PDM, are immediately transferred to PCM in order to be able to either not so much edit them, but use tools like added reverberation, equalization, something to sweeten the perceived audio to the producer and artist's desire for it being a representation of what they want.
Which you just sort of answered. My next question was going to be, you know, microphone recordings for the last 25 years or so start as DSD and then get converted. And, you know, the question to my mind is, why are we doing that? You know, why are we, you know, obviously, I guess, you know, that gets back to why are DSD files so much larger than PCM files? And, you know, the answer is, you know, we're stripping off all this added stuff in my mind, it sounds like, but then we're sweetening it, as you just said, to make it sound better again. So it's like we're taking away, but then we're putting back. It just doesn't make sense to me. Why aren't we just doing everything in DSD?
Well, several, but the most important factor is available tools. The recording industry started in a PCM environment, and tools were developed for PCM. There are virtually no tools available for processing PDM because, again, there's no values associated with the bit stream.
Right.
And that has to be made into a value-based system for a digital computer to process it. The tools that are available, of which the most notable is HQ Player, their Pro version, which is the mastering version of HQ Player, basically is a remodulation of the signal. So it's exactly like tape. Every time you do anything to tape, combine channels, you suffer a 3 dB loss in signal to noise ratio. So the disadvantage of post-processing in PDM is accumulated losses. If you can get around that, which you can by simply saying, I'll organize my recording such that I don't have to add reverberation to it. I don't have to add equalization to it. I choose the microphones and their placement and the venue to meet the desired result as played. Then all I have to do is mix the channels together. I don't have any processing. And that's what we do in those recordings that we specify as DSD pure. That is, they're recorded in DSD. The DSD direct recordings are either single microphone or multi-microphone, but those DSD channels, tracking channels, are mixed together in DSD, remodulated, and sold or offered as different DSD rates of the original, never having been converted to PCM. The alternative to that is the pure DSD in mixed mode, which has the multiple channels recorded in DSD, then played back out of DSD through an analog mixer, a desk, and then mixed and sweetened or not in analog in the desk and re-recorded in DSD. Again, the object is to get around the discontinuous nature of PCM.
Right. So back to the consumer side. So consumers that are buying DACs, unless a DAC can do true native DSD conversion to really get the best out of what you guys are offering on your site, you know, there's some conversions going on there, right? They've got to convert it to PCM if they don't have a DAC that does native DSD. And then, you know, what is that now doing to that signal and changing the sound quality, if you will?
Well, DACs come basically in two flavors. The minor is a ladder, or in the DCS implementation, a ring DAC. And the major, by 95%, are all sigma delta modulator based DACs. The problem you have in a sigma delta modulator DAC is that, with a very small exception, they're all chip based. And on that chip, the end of it, the analog end of it, is a sigma delta modulator. The input to that sigma delta modulator has to be a PDM, either one level or multi-level bit stream. If you feed that DAC a PCM signal, it has to convert it inside. So what NATIVEDSD offers is, instead of relying on the limitations of the resources within the chip to do that, we do that externally with a much more detailed set of algorithms and a much larger computer resource in non-real time, meaning that you could do it on your watch if you had enough time, or any small computer if you had enough time.
Right.
The problem with a sigma delta based DAC is it has to do it in real time because it's being fed the stream in real time.
Right.
So to tie it to NATIVEDSD, what we do is, first of all, with the vast majority of our labels, insist on the edited master. And the edited master is the last iteration of a recording in a chain of processing, where the recording exists now as a deliverable entity, a listenable entity, but not further degraded for distribution purposes. So instead of taking our recordings from distribution, which are people like Fuga or Naxos or Orchid, those folks distribute to like companies of NATIVEDSD, either as recorded, let's say 96K, or to save space for both the distributor and, more importantly, the end store, the DSP or customer, reduce the size of the PCM signal, PCM word stream, to something from what it was recorded down to 96K. Instead of us taking the distributed version of the recording, we get the original edited master. Then we make from that the highest rate, most usable PCM from that PCM, whatever was delivered to us, which is basically upsampling. But we do it, as opposed to on a DAC chip in real time, we do it offline in non-real time using a more capable set of computers. And we also take that original recording, which again usually comes to us as a high rate PCM. We then modulate a DSD 64, 128, 256, and 512, and occasionally a 1024. We do that not in the sense of it being in a horsepower race. This has got to be better because it's faster or has more bits in it or whatever. Sigma Delta DACs have a reconstruction filter as its final entity in its process. That reconstruction filter is basically a hardware function at the end of the DAC, basically resistor, capacitor, integrator. It's in hardware most times for the highest rate that the DAC supports. So a DAC that supports 512 has a built-in filter that's optimized for the shallowest filtering shape for 512. Anything that it plays that's slower than that, it has to add a software filter, which implies greater losses. So basically, we supply DSD rates in the 4 or 5 variants, speed variants, such that a customer can choose that rate which best optimizes their DAC. And therefore, someone who has a DSD 64 DAC, they wouldn't have any advantage at all buying the DSD 512 version of it. They would buy the DAC that is, or the version of the recording that is the sweet spot of that DAC. That's why we offer the various DSD rates.
And that'll really tremendously help with the next couple of videos we'll be doing with 3 companies that are really big into DSD audio, whether it be DCS with their Ring DACS, Bricasti with their ladder DACs that they do that's different than the Ring DAC, and then the way Chord does stuff with DSD. It's very interesting. That was amazing information and will really help with those upcoming videos. So getting back to now, Jonas, we've talked a lot about technical nature of PCM and DSD. Tell us about how Native DSD is sourcing and recording their music. I think that will really help tie all this together.
So yeah, I talked a bit in the beginning about Channel Classics, and there's, there are a couple other labels very early on that helped Philips and Sony develop DSD recording and, output onto SACD. And throughout the years, of course, many other labels have started, purchasing, either merging ADCs or other brand. I mean, there's many brands now that produced an ADC, so an analog to digital converter that can run in DSD. And so we just started to contact all these labels. And of course, one label also leads you to the next, because they'll say, okay, do you know these guys, those guys? So that's how we kind of created that big catalog of products that are available now. Kind of lost track of your question for a second.
Obviously, and maybe this is a little bit simpler, I guess going back to what you guys are doing, you're producing it at the purest level, and providing this to consumers.
So I see. So there's labels that actually record in DSD, and sometimes we're able to label those recordings as pure DSD, as to Tom's point, where the whole process actually stayed in DSD, because if as soon as you start to edit, then those edits need to be rendered in some kind of PCM form, right? Because the computer won't be able to understand this continuous flow. It needs to kind of chop it up into segments to be able to do either a crossfade or some mixing, some level change. So there's I guess sort of variance in what we call native and what we actually don't call that, or what we call pure. And all of that, of course, we stipulate quite closely on our website. On each product page, we'll list the actual original format in which it was recorded, and in most cases we'll also list how it was post-produced.
And sort of an easier analogy to tie this together is, you're getting sort of rid of the middleman, right? You guys are doing your own recording. You're offering the purest possible format on your website, whereas other people are, they're starting in DSD. Now they've got to do all these conversions. There's so many more touches to everything where something can go wrong, or the coloration changes or whatnot. I think the important thing for people to understand is they're getting the purest olive oil from Italy from you guys, right? Something like that.
Yeah, I mean, we're doing a bit of our own recording, but I have to say it's a small percentage in terms of the entire catalog that's being offered. But we are indeed talking directly to the engineers and directly to these labels to obtain their edited masters and the actual original data, and put that directly onto our server and sell it directly to the consumer.
I find it challenging with classical music in that, there could be one piece that's been recorded by 20 different composers. How do you guide listeners? How do you know, like, I don't really want to own 40 versions of that one piece. How do you guys sort of meander around that situation to sort of, help the end listeners try and figure out which music to buy? I mean, it's crazy in classical.
I mean, we of course have a lot of contacts in the review side. So it's music reviewers that discuss certain recordings, and they'll have lists and say, okay, you should try this or you should try that first before all the other versions. But I think what's more important is to know that it's not just about the contents or the artists. It's also indeed about the quality of the recording. I mean, recording in DSD doesn't mean it's a good recording. You can still screw it up if you put the microphone in the wrong place, let's say. So we're trying to, have the best of all those, all three: the repertoire, the artist, and the engineer, let's say. So I think, the best one would be where those three subjects are scoring high.
maybe each of you could list off, has there been one DSD recording from your library that's just really amazed you? Maybe each one of you give a good example for listeners to check out on the website that, something that just really stands out.
Yeah, sure. I mean, in terms of classical, probably.
Maybe classical and jazz.
Yeah, so for classical, probably the Channel Classics is Four Seasons. I think that's a really high seller, and also definitely worth a listen for a very well-known classical piece in DSD. In jazz, I don't know, Tom, do you want to take a guess?
As a mastering engineer, I don't have a preference. It's not that kind of business.
I mean, I'll just jump in there. I think, one of the most popular items in terms of jazz is the Jazz at the Pawn Shop, which is quite an old recording done on analog tape back in, I don't know, the 70s, and was transferred directly to DSD from that original tape by 2XHD, a label out of Canada. And yeah, that when I listen to that recording, definitely takes me directly to that bar where they're stringing that bass, and you hear the sound of the people around you playing their classes, and it's really a really special one.
Would you say that are any of the different formats, in terms of 512, 256, 128, DXD, are they optimized differently for DAC architectures? I mean, is there sort of where does it start at when you do the original master? You're recording at the toppest level, right? And then you're shrinking some things down. How does that play into it?
Well, again, there's a slight misconception here. While Native DSD has two private labels, we don't record things. We're a store. We sell things, and what we sell are what a label provides to us. The qualifier is that we don't take their recording from the normal distribution channels. We get it directly from them. So by and large, those recordings that we sell started out from the purest or highest level of fidelity that the recording existed at, which was when it was edited, better known as the edit master. We take those recordings and we sell them as we receive them. In addition, we add value to that recording by also offering it in, it typically comes to us as a PCM, we offer it also in DSD. We produce those modulations using the professional equipment that the recording company is also using, Pyramix typically, to provide the widest breadth of alternatives to consumers to match to their DAC, to match to the sweet spot of their DAC, or determine the sweet spot of their DAC and buy that version of it. Be it PCM, which is the optimal if you have a ladder DAC, or PDM, DSD, if you have a Sigma Delta DAC. The vast majority, as I say, of DACs available today are Sigma Delta modulator based.
Has technology gotten to the point now in terms of home networks and so forth that you guys could potentially offer streaming of DSD from your website? Have you thought about DSD streaming? Or is it just, we're not there yet?
There's a problem with DSD, which you alluded to very earlier in the conversation, which hasn't really been pointed out. DSD files are large by comparison to PCM files. The reason they're large is that the vast majority is the carrier. So the audio is actually a smaller consideration or a smaller ingredient in a PDM, DSD bitstream. So that's another disadvantage of DSD. To gain its advantages, you have to suffer the disadvantage that you have to carry around that carrier.
I guess so. That's a crow pet. Like, it's a lot of data to move around. So streaming a lot of data, of course, costs a lot of money, and the market for DSD listeners is probably still small.
Well, I mean, it's all about education and explaining all this stuff to people, because I don't think people understand that, DSD is really the cleanest, best format. I mean, I've always thought, I prefer DSD I mean, I can clearly hear the differences. I'm sure plenty of people that are really into music are going to pick up on it. And I'm just, it gets back to the confusions. Why aren't we just doing DSD instead of PCM too? But I get all the tool stuff that, for the studios to add coloration and flavors and sweeten stuff up, and you got to do all that in the PCM format. But I'm all DSD. I mean, it sounds more like, a lot of people get hooked on, I want the digital to sound more like my vinyl, right? Well, DSD is the way to get as close to that sound signature as possible, in my opinion.
Without the disadvantages of those various media.
Exactly. The clicks and the pops and the having to clean the records and blah, blah, blah. Yeah, we can go. And it's a format that deteriorates over time. As that needle goes through the grooves, it's just chewing up that plastic, right? But I see, you guys don't just offer digital downloads on your site. You also offer media. Maybe talk a little bit about that.
We have a very small selection indeed of some vinyl, and as well as a couple tapes, again, from the label 2XHE that I mentioned earlier. And the vinyls come from a bigger group of labels, and we specifically sell those titles that we also offer as a DSD download to be able to give the audiophiles among us a chance to audition the two, or bundle them up and get the best of both worlds, let's say.
And something that we're talking to Jonas about is doing a native DSD sampler collaboration where we can help some of our consumers really see the benefits of DSD and what it can do. So that's going to be fun to put together.
Yeah, let's do that.
One of the things I'd recommend, to go back to the what would be the favored thing to buy, both Eudora and, well, primarily Eudora, EUDDRA, do a direct, primarily small ensemble set of recordings that are all pure DSD, direct mixed. That's as close as one is possible to get to what the microphones actually heard. So as an example, I would take virtually any of the Eudora recordings and choose that as
Starting point.
This is what's possible to hear what was actually heard in the analog feed in a studio.
Jonas, what have we missed? What else can you tell us that we're not talking about here?
I think what we haven't really discussed, specifically, is why it sounds better, or what we say are the things that make it sound better. A lot of times it's hard to really hear the difference. Drew, you said you do prefer it, but so why is that then? It's people say it's an outstanding quality, but can we describe that in more detail? Mm-hmm. Because then people actually know maybe what to listen for, let's say.
I mean, it's the nuances, right? I mean, I hear more of the nuance in there. Right. I mean, there's a couple of, like, there's a DSD recording from Patricia Barber. I use this one all the time as an analogy. Mm-hmm. Companion CD, I think it is, in that this was recorded in a jazz club. And one thing, and I have a hard time picking this up on speakers, but on headphones, this is where I really notice it. And so I can actually hear, since it was done in a club, I can hear a waitress behind one of the microphones behind me, right, picking up some of the dishware off of somebody's table or something. And I was like, what the heck? I've never heard that before, but it was so clear in the DSD recording. So ultimately, for me, it's those little nuances that I pick up on, right? I think the decays of the instruments and stuff like that, it's just so much more apparent to my ears.
Yeah, I would say you need a lot more detail in the overtones, a much broader bass, a better staging. You can really, if you're listening to an orchestral recording, you can really point out exactly where, the trombone or that that second violin is sitting in your field of sound, even in stereo. We're not even speaking of multi-channel, of which we also offer quite some titles, a 5.0 or 5.1 mix.
In acoustic music, where the ensemble, regardless of its size, is in an environment, the cues are in the environment. The thing, you can feel the space around the orchestra or the ensemble much more so in DSD simply because it was originally transcribed in DSD and there was less taken out of it in the production process.
It's specifically for those that want a dedicated experience in listening to music, and it also offers much less or maybe zero fatigue or listening fatigue due to the way it's coming out of your DAC. It's much closer to human hearing was designed to be.
This may be a biased question in some ways, but what DACs are you guys using at home? What's your favorite go-to DAC in doing the DSD conversions?
Well, I mean, in our studios, we use a lot of the earlier mentioned merging equipment, the Horus and the Happy. But we've also used a lot of the Grim audio products, also out of the Netherlands. Mm-hmm. They have a great MU2 DAC, I think it's called now. We've also used a lot of the chord stuff. And, if you're on a budget, the iFi is a really a good way to get started for,
huge bang for the buck.
Couple $100, you're on the way. Yeah, for sure. We have a complete, we list all and any DAC that is ever made on our site, nativedsd.com/database. It's a really,
cool.
really nice, just a Google sheet, but it lists every single piece of equipment that has anything to do with DSD. We'll list it right there.
Do you also separate it by native versus chips and stuff like that, or
we do specify, I think, closely the different rates it does. I'm not sure if we're specifying chips on that in that sheet, but maybe that's nice to add. Yeah.
But what are you using at home? What DAC do you have at home?
At home currently, I'm using the Grim Audio. Yeah.
Grim Audio. How about you, Tom?
Submerging. My setup is a professional Pyramix, which is supplied by Merging Technologies equipment. So it's the software and the hardware, which is an ESS 9038 based Sigma Delta modulator built into the board that's in a Happy.
Very cool. Very cool. Unless I've missed anything you guys want to speak up about, I'll go into the outro. Is there anything we've missed?
I'd only mention that Native DSD is basically the implementation of a dream that I had some 60 plus years ago working for Macintosh Laboratories and owning a pair of KLH9s and a pair of Mac MC75s, dreaming about what could it sound like if I could actually hear what was heard out of the microphones in the studio. That's what Native DSD does. We supply that.
Jonas, Tom, thank you both so much for helping our viewers understand why real high-resolution audio matters. For everyone watching, if you found this conversation valuable, make sure you're subscribed to the channel and you've hit that notification bell. We've got more technical deep dives coming with people who are doing things differently in audio world. Jonas, Tom, thanks again for the masterclass in high-resolution audio. We'll see you next time.